Today I want to highlight 5 essential tweaks that can help you achieving better VR performance with an ultra-high resolution headset like the Pimax Dream Air. There are actually more than 5 tips and tweaks that I want to share with you, but they are divided into 5 segments or categories. And some of these tweaks can be completely different or even contradictory depending on whether you're running the latest cutting-edge PC or a less powerful system with an older CPU like my Ryzen 5950X. After 10 years in VR, I think I have quite a bit of knowledge when it comes to VR performance optimization, and I base all of this on my own personal experience, mostly trial and error attempts. But please bear with me if I happen to be wrong at any point, and if so, please feel free to correct me. First off, H.A.G.S, or Hardware Accelerated GPU Scheduling. I bet some of you have never even heard of this Windows feature, while others do know about it but struggle to understand what it really does and when it should be kept enabled. Without geeking out on the technical part too much, Hardware Accelerated GPU Scheduling is a Windows settings that lets your GPU manage its own frame timing, freeing up your CPU to focus on running the rest of the game. Yeah, it's a very simple explanation, but let's leave it there. On a fresh Windows 11 installation, Microsoft explicitly enables H.A.G.S by default, which is great when you are lucky to have some of the latest AMD X3D processors with VCache, such as the 7800 X3D series or higher. Now there is a catch. Most people still don't have these top-tier AMD CPUs. If you are running an older CPU like my own Ryzen 9 5950X, keeping H.A.G.S enabled can instead hurt your VR performance. This is especially true in VR flight and racing simulators. In heavy sims, maintaining a smooth, consistent frame pacing is key. And even if your frame rate is on the lower side, far from matching the refresh rate, let's say 60 frames per second in the 90 Hz mode, you need that frame time or frame rate to be consistent to prevent other stutters and microjudder that distracts your VR immersion. The problem with the older chips, like the 5950X, is their physical design. They split their cores across 2 separate pieces of silicon called CCDs. When hardware accelerated GPU scheduling is turned on, it fundamentally changes how the PC queues up the frames, switching work directly to the GPU. However, Windows often struggles to manage VR background tasks alongside the game, accidentally bouncing threads between these 2 separate CCDs. That creates a tiny delay. On a flat monitor, you never see that delay, but inside a VR headset, where every single millisecond counts, that latency breaks your frame pacing, resulting in microstutters and a less enjoyable VR session. The newer X3D CPUs don't have that issue because they pack the massive 3D VCache onto a single unified CCD, allowing them to handle that H.A.G.S feature properly. But the headache with H.A.G.S doesn't stop there. H.A.G.S is also bad for VR injectors in general, like the UEVR mod. Even the creator of UEVR and the modders themselves explicitly recommends turning off H.A.G.S when playing UVR modded games, and that prevents performance issues and potential crashes. So here's my recommendation. If you have a modern AMD AM5 socket CPU with X3D VCache, such as the 7800 X3D or better, then keep H.A.G.S enabled. But if you're still on an AM4 platform or running any older CPU without X3D cache, then disable H.A.G.S right away. For the vast majority of setups, especially when running VR simulators and UEVR modded games, turning H.A.G.S off seems to be the safest way to guarantee smooth gameplay with less stutters, issues, and even crashes. In fact, even the older Ryzen 5800 X3D that is an X3D CPU, but on the old AM4 platform can get worse performance with H.A.G.S enabled. Alright, tip number 2. Let's dive into the NVIDIA control panel because there are 3 crucial settings here that can completely make or break your performance in VR. First off, let's talk about G-Sync. While G-Sync is amazing for standard flat monitors, you should absolutely turn off G-Sync whenever you're doing VR gaming. Your VR headset runs on its own independent display logic with its own strict refresh rate. Leaving G-Sync active on your desktop monitor can cause driver confusion, creating weird conflicts that disrupts frame pacing inside of your VR headset. G-Sync will not ruin your frame rate really, but it can affect the frame times and the frame pacing. So when doing VR sessions, I always leave G-Sync disabled, at least temporarily. Next, head over to the Manage 3D settings and look for the Power Management mode. By default, this is usually set to normal. You want to change this to Prefer Maximum Performance. This forces your GPU or your graphics card to maintain high clock speeds rather than constantly downclocking to save power. Changing the setting to Prefer Maximum Performance that forces the GPU clocks staying high often prevents sudden frame drops, especially in demanding flight and racing simulators. Finally, in the same tab, scroll down to Virtual Reality Pre-rendered Frames. NVIDIA defaults this to 1 to prioritize the absolute lowest input latency in VR. But here is a pro tip, I would say. If you are running a mid-range or an older CPU like my 5950X, change this to Use the 3D Application setting. This hands over the frame buffering control directly over to the game engine, which can handle the frame pacing much more efficiently than the standard driver rule. This leaves some headroom for your CPU, and if your CPU is struggling by heavy VR simulator physics in general, this extra headroom can many times reduce those annoying head tracking judders and stutters, for example when you look around in the cockpit. Keep in mind, forcing a larger frame queue can slightly add to your input latency. And on ultra-high resolution headsets like the Pimax Dream Air, especially with Tobii eye tracking enabled, that latency can be noticeable for some people. However, in my opinion, the trade-off is absolutely worth it, because with my old CPU and this setting adjusted, the reduction in stutter and judder makes for a much better overall VR experience, especially in VR flight simulators. Now, number 3. If you want the ultimate control over your performance when running CPU with multi-CCDs like my 5950X, you simply need Process Lasso. It's kind of like Task Manager on steroids, but super easy to use. And it temporarily automates your system rules so that your CPU can work more efficiently on per app level, either temporarily or permanently. The biggest game changer here is managing the CPU core affinity. Again, the CPUs like the 5950X are physically split into two separate core clusters, CCD0 and CCD1. In physics-heavy flight and racing simulators like the Microsoft Flight Simulator 2024 or Assetto Corsa Competizione, forcing the game to only use CCD0, the cluster with the first half of the CPU cores, prevents the CPU from bouncing data back and forth between those two clusters. Isolating your VR simulator executable file to a single CCD, preferably the first one called CCD0, basically eliminates that latency. And to some degree, it stabilizes your frame pacing, which is so important when flying and racing in VR. Now, you can use Process Lasso to force a high CPU priority specifically for your VR games and simulators that are CPU demanding. For example, by setting CPU priority for MSFS 2024 or DCS World to high, you force Windows to serve your VR simulator first, so to say. This way, you make sure that the intensive background tasks like Windows updates, Discord, or web browsers, or whatever you're running in the background never steals any necessary processing power from the game or your simulator you're playing. This will most likely not give you higher frame rates, but it can prevent occasional stutter and micro judder. Now, number 4. Let's talk about the Microsoft Xbox Game Bar. For a long time, the common advice was to just turn it off completely. These days, with the AMD's X3D chips, things have changed slightly. If you're running a processor like the 7800 X3D series or better, you actually need the game bar enabled. It kind of dictates AMD core parking logic, telling Windows to keep the game locked to the first 3D V-Cache cores. But if you're on an older CPU, like a non-X3D CPU, Game Bar loses that purpose and becomes a rather useless background process that can even hurt that low 1 percentile frame rates in heavy VR simulators and games. The issue gets even worse if you're recording or streaming your VR gameplay specifically using OBS Studio. By default, Windows Game Bar runs a background capture feature that constantly records your gameplay. This background recording forces your GPU to use its dedicated hardware video encoder. Because the GPU only allows a limited number of encoding sessions at once, Game Bar will end up actively fighting with OBS for resources. So, turning off Game Bar frees up that hardware encoder entirely for the OBS Studio, keeping your OBS recordings smooth. And finally, number 5. Let's wrap up things with a game changer for Pimax headset owners thanks to the latest Pimax Play Evo software. If you're running headsets like the Dreamer, updating to the Evo client is a must in my opinion. There are several new features available with Evo as of now, but the biggest breakthrough here is the feature called Open Port. This opens up the display pipeline so that you can easily run the famous community-made H.A.G.S 3 native SteamVR driver directly through the software. And now it also supports both Lighthouse and inside-out slant-tracked versions of the Dreamer, which I will cover in another video. You may ask, why is a native SteamVR driver such a big deal for us? Most people have been avoiding SteamVR anyway due to worse performance compared to Pimax OpenXR and Pimax XR runtimes. Well, apart from a lot of useful tweaks that you can do in the custom headset software by H.A.G.S 3, the native SteamVR driver allows Pimax headsets to finally gain full access to SteamVR motion smoothing. If you play a heavy flight or racing simulator or play games with the mods like the UEVR, you know that keeping a native 90 frames per second at this insane resolution can be rather impossible even on an RTX 5090. The H.A.G.S 3 driver solved this by unlocking a highly efficient motion reprojection feature, and in fact it's the best motion reprojection available for PCVR, and yes, it's considerably better than the Pimax Smart Smoothing. With SteamVR motion smoothing, instead of maxing out your GPU trying to hit native 90 frames per second, you can comfortably lock the game's frame rate to half or a consistent 45 frames per second. SteamVR will then interpolate the missing frames to deliver a way smoother 90 Hz experience in your headset. Aside from a few minor artifacts in some games, visual artifacts, it kinda looks and feels like a 90 Hz and a 90 frames per second gameplay. And this delivers a more or less butter-smooth, stutter-free gameplay that can completely change the game for you in games and simulators, especially with the Pimax Dreamer. I covered that in a recent video trying some UEVR mods on the Dreamer, and it made these games going from barely playable to totally playable. This simply wouldn't be possible with an old CPU and my RTX 4090. I cannot tell you enough how great this feature is. It is a game changer, especially in VR flight and racing simulators and UEVR compatible games. Anyway, I know there are tons of other tweaks and hints and tips that I could squeeze into this video, but let's call it a day. Guys, I hope you found this video somewhat helpful and with some value. Please leave a comment if you feel that I need to be corrected in any way, or if you have any good tips to share. Thank you so much for watching, and I'll see you in the next one.